This is problem number 7 on the sample test problems for test number 1. State whether each function could be linear, exponential, or neither. If the function could be linear or exponential, give a formula for it. Let's take a look at part A. We've got x values and we've got f of x values. So to decide whether or not it's linear, what we're looking for is the same slope for every pair of points. My observation here is that the x's are all changing by +1. So if it's going to be linear, then the y's should be changing by some constant amount. First change here going from 64 to 80 is 16. Second change is 20. And I don't need to do any more. Those first couple of pairs of points have different slopes, not linear. To decide if it's exponential, same kind of idea, but now instead of saying we're adding the same amount to the y values, what we're looking for here is the same multiplier for the y values. So what can I multiply 64 by to get 80? And is that the same thing I can multiply 80 by to get 100? And so what we're really looking to do is calculate 80 divided by 64, and we're going to compare that to 100 divided by 80, compare it to 125 over 100, and then finally 156.25 divided by 125. So we're going to type these things onto our calculator and just see if we get the same ratio every time. If we do, it's exponential. As soon as we get two different ratios, it's not exponential. So 80 divided by 64 is 1.25. 100 divided by 80 is 1.25. 125 divided by 100, that one should be easy enough to see, is 1.25. And then finally 156.25 divided by 125. And that's also 1.25. So this one here is an exponential function because they all have exactly that same ratio. And so our job now that we know it's an exponential, is to find a formula for it. So to find a formula for it, well, that 1.25 is actually quite helpful because that's the base. So we know our function is supposed to look like a times b to the x. And we just found out the base is 1.25. Last thing we need to know is the value of a. If you remember, a is always the value that corresponds to x equals 0. And so in this case, we happen to have it. So we will accept that gift and put the number 64 right there. So here's the formula for the exponential. Okay, for part B, same idea. Let's ask ourselves if this is a linear function. So here we'll notice that the x values have different differences between them. So one thing you could do at this point is find the slope. Find the slope of the line connecting the first 2 points. 2 minus 0 over 1 minus 0. So the slope of the first 2 points is 2. And then compare that with the slope of, say, the second and third points. 4 minus 2 over 4 minus 1, which is 2/3. And that is not the same as the slope that we found in the beginning. So because 2/3 is not the same as 2, these points have different slopes, which means we're not looking at a line. Go ahead and put a divider in here just so we see which is for part A and which is for part B. Okay, so it's not linear. Turns out there actually was a nicer way to do that one, and that was to recognize that if we look at the changes in the y values, it's always a constant +2. So that means that if it's going to be linear, then the x's will also change by a constant, but they don't. So that's the easier way to see that it's not linear, but slope is a pretty automatic, straightforward way to go. To decide if it's exponential, we're playing the same game we played before. We're going to do ratios. The first ratio, ratios of y values. So 2 divided by 0, 4 divided by 2, 6 divided by 4, and 8 divided by 6. So one glimpse at that first fraction should send shivers down your spine. So 2 divided by 0, it's a problem. And in fact, right away, it means it's not an exponential. That ratio doesn't even exist. Certainly, it's not the same as the other ratios. But that makes sense, actually, because we know exponential functions never hit the x-axis. Maybe it looks like that, or maybe it looks like that. But under no circumstances is the y value ever equal to 0. You never get to hit the x-axis. So as soon as I see a y value of 0, I'm done. But even if that wasn't there, I would recognize that 4 divided by 2 is not the same as 6 divided by 4, and that's enough. So this one is also not exponential. Okay, let's take a look at part C. For part C, looking at the x values, I see that they increase. X values are increasing by 3 every time. And so if the y values also increase by a constant amount, then we've got a linear thing. And it looks like the y values are increasing by 5. So these are all plus 3s, and these are all plus 5s. So this is a linear function. And in fact, if you understand what we just did, then you should see that that 3 and 5 are quite helpful in terms of identifying either the m or the b. And it turns out that the slope of this thing is 5/3. You can do that by just checking your basic formula, the rise over run formula, or the change in y over change in x. But however you do it, you're going to get 5/3 as the slope. We don't have a gift. We don't have the y-intercept here, so we need to do a tiny bit of work to find it. I'm going to go ahead and plug the first point in. You can plug any point into the equation. So instead of y, we have 8 equals 5/3. Instead of x, we have 3 plus b. And so do a little bit of work there, and you should see that b is equal to 3, which means the final equation of the line is y equals 5/3 x plus 3. And then finally part D, same idea. If we look at the increases in the x's, looks like these are all plus 2s. And the y's, let's see, that's down 24, that's down 12. Not linear, because it's not the same difference. But I do notice that it sure feels like every time we take a step to the right on the y's, we're cutting in half. And so that feels quite exponential. So in terms of checking, you could just do your 48 divided by, sorry, we're going to do the next y first. So we're going to do 24 divided by 48 and compare that to 12 divided by 24. And every time we get half. So because they are all equal, this is an exponential. I don't know how to spell. And so to find the equation, well, it seems like what we said before is that we just found the base. Is it true that the base of this exponential is a half? Because I think that's what we set up above, isn't it? We ended up getting the base of 1.25, which was these red ratios here. Unfortunately, I don't think it's true. I think that the base is related to a half, but I don't think the base is a half, because in this case, the steps that we're taking in the x direction are not plus 1s, plus 2s. So let's do a little bit of work. I think there is a shortcut here, but let's just write it out. We'll see all the details. So we know that our formula is supposed to be a times b to the x. And we're just going to pick 2 points in this list. Let's go ahead and pick the first 2 points. So we're going to plug 1 and 48 into this equation. And we're also going to plug 324 into this equation. So in the first one, the y value is 48. That's equal to sum a times sum b to the x value of 1. And in the second equation, 24 equals a times b to the 3. The general way to solve from here is to do substitution. For example, you could solve this equation for a, and then whatever you get, plug into the other equation for a. I'll just go ahead and take the shortcut, which just happens to work in this kind of problem. We're going to divide. So if we divide these guys, 48 divided by 24 is 2. A divided by A, that cancels. That's why this is a good thing to do. And then B to the first divided by B to the third is 1 over B squared. So multiply by B squared, divide by 2, and we get B squared as a half. Okay, that half that we just found is the same half as this ratio that we got over here. So how come it's not B, but rather it's B squared? It's B squared because of these jumps by 2. So the base is not a half, rather it's the square root of a half. Okay, and then to find the value of A, we can just plug into either of these equations, say, let's go into this one, 48 is equal to A times, we just found B is the square root of a half, and that's to the first power. So that means that A must be 48 divided by the square root of a half. If you want decimals, you're welcome to get them. If you want to clean up that square root of a half, it's kind of messy, you can do that too. I'm content to just end here, writing down our final equation. Y equals the A that we just found times the B that we found raised to the X.